Okay, Yanjia 312. This is lab number 4, the pump, the first pump experiment. I like to. There's a separate video for the experiment. Okay, but I like to add a couple of instructions here. Okay, so the goal here is since this is the first pump measurement, so we are going to measure a single pump curve. Okay, then based on the single pump curve, you should be able to produce a pumping parallel curve without actually doing the experiment. Okay, so we talked about it in the lecture last week. So if you don't know how to do it, go back to the lecture. Okay, so single pump curve you should be able to measure and make plot. Okay, then based on the single pump curve, predict the pumping parallel curve. Then in the actual video experiment, it shows you the measurement, the experiment to measure pumping parallel pump curve. Okay, the resultant curve of pump in parallel, two pumps. Okay, so you will see in the video that system has two parallel pump. Okay, the two pump can be set it up as pumping series and the pumping parallel, or just with running with one pump. Okay, if you turn off one pump, you can run with one pump. Okay, so the video experiment video is not complete because I don't see the single pump part in the experiment. So it's somewhere in my office computer, but it's not with me now. So let me explain to you. When you measure the single pump curve, you just turn off one pump. Okay, just running with one pump. Turn off all the valve for the second route. Okay, so then you can measure the pressure before and after the pump with 5 different flow rates. Okay, again, when you measure the pump curve, when you change the flow rate, as we discussed last time in the lecture, you turn that valve. There's a valve behind the tank. It's a control valve, and you can turn the valve open and close to control the flow rates. Okay, so that 5 data sample is from 5 different flow rates, so you control it by the valve. Okay, so basically we record the data for 5 times for the single pump measurement. Okay, since I don't have the video, I provide you the actual data we measured. Okay, I uploaded that data file, the picture for the single pump, so you don't have to measure the single pump. I give you the measured data already, so you can produce the single pump curve based on that set of data I post. Okay, now then you can produce the pumping parallel curve, right? Predicted curve based on the theory. And then you measure the lab experiment showing you how to measure. Then you change actually it's 6 times instead of 5 times in the pumping parallel measurement. That's fine. So we turn the valve behind the tank for 6 times. Every time you will read the flow meter for the flow rate. And then you will read the pressure, 2 pressures, 1 pressure before the pump, 1 pressure after the pump, 1 in the suction, 1 in the discharge. So pressure difference is the delta P. So you can convert the delta P into pump head as we discussed last time in the lecture, right? So that's how you find the 1 pump head with 1 flow rate. So you have 6 flow rates, then you have 6 pump heads. You can make a curve, pumping parallel curve. Okay. Again, I want to emphasize here is pumping parallel. 2 sides are parallel, so they're supposed to have similar pressure readings. Since one of the pressure gauge is broken, so I only read one side. The other side will be the same, similar at least. Okay. Okay. The other thing I want to mention, I briefly mentioned in the video, is I think the suction pressure gauge is not aligned, not calibrated well. Okay, so even without the running, it shows negative 21 inch Hg. Again, this is inch Hg. You need to convert into PSI, right? So so that's use that negative 21 as your reference pressure. When the pump running, you read the value, it should be close to 21, negative 21, maybe negative 20, maybe negative 22, in the range, very close. Okay, so minus, exclude that reference value. That's your pressure reading in the section of the pump, which is close to zero. Okay, it's a suction, so it should be about maybe a little bit less than zero, but it should be close. Okay, then the discharge has high pressure because then it goes through the pump. A pump will, add pressure to the fluid. Okay, so I think the single pump data already show you it's in the suction or -1 psi. That's already exclude the reference pressure reading, but in the actual pumping parallel experiment, when you read the data, please exclude the negative 1021 inch HT. Okay, so that will be your suction pressure. It should be similar to the single pump suction pressure. The discharge will be different. Okay. Okay, so I guess in the report, the most important thing I want to see is a plot. In this plot, you will have 3 curves. Okay, first curve is a single pump curve based on the data I provide you. The second curve is the predicted pump in parallel curve. Okay, then the third curve is the actual measured pumping parallel curve. Okay, so this is the calculation result I want to see, and plus you need to put in a lot of discussions. We have 30 points on each report for the discussion, right? I think I did talk about it a lot in the previous lecture and as well as this video. Okay, please include some of the theory, and you can add additional physics theory related to the experiment in the discussion part. Okay, so okay, I guess that's it. So this is the video, and you will watch the experiment video. Okay, for the experiment.